Welcome back to the deep dive. This is where we comb through all the tech specs, the manuals, the fine print. Basically, we do the reading so you don't have to.
And our mission, as always, is to find that one key insight, that shortcut to really understanding what's going on.
Exactly. So today, I want you to picture something. You're sitting at your desk, you got a great keyboard, a mouse, a beautiful crystal clear 4K monitor.
The perfect setup.
Right. You type, letters appear instantly, everything feels perfect. But here's the twist. The actual computer. It's not under your desk. It's not even in the room. It's over a mile away.
Wow. Okay, that sounds like, I don't know, magic. Or maybe some kind of advanced cloud computing.
It feels like it, but it's pure physics. The physics of light, actually. We're doing a deep dive on a piece of hardware that makes this exact thing possible.
We're looking at the NTI fiber extender.
Yeah, the full model name is like a whole alphabet soup of letters and numbers, so we're just going to stick with NTI fiber extender. At its core, it's a KVM extender. Your keyboard, video, and mouse. And we want to unpack how this box pushes just a massive amount of data over these crazy distances.
And massive is the right word. We're talking 18 gigabits per second?
See, that's the number that jumped out at me.
Yeah.
18 Gbps. Normally, when you send video that far, you'd expect some serious compression, right? A little bit of lag, maybe some blurriness.
That's the usual trade-off, absolutely. But this thing is built for scenarios where good enough just isn't. It's pushing full Ultra HD 4K at 60 hertz. And
I saw it supports 4.4.4 color space. I see that spec everywhere. What does that actually mean for the person just looking at the screen?
Okay, so think of it like this. Most streaming video, like on Netflix or YouTube, it throws away about half of the color information to save bandwidth.
Right.
Your eyes usually don't notice it. But 4.4.4 means it keeps all of it. Every single bit of color data. It's like the difference between a compressed JPEG and the original raw photo file.
Okay. So it's for situations where you need perfect fidelity.
Exactly. We're talking HDR, Dolby True HD, the works. The whole point is that you literally cannot tell the computer isn't right there in the room with you.
That sounds incredible. I'm guessing uncompressed 4K over a mile isn't something I can just pick up for $50.
Not quite. No, you're looking at over $1,000 for the set. This is serious enterprise-grade hardware.
And the reason it works so well is the fiber optic cable, right?
Yes. It uses a duplex single-mode LC fiber cable. See, a normal copper cable uses electricity, which has resistance. It gets interference. The signal just fades.
It gets tired.
It does. But fiber shoots photons light down a glass tube, and light doesn't really have resistance. It just goes.
So because it's light, we can hit that full mile-plus distance.
Well, here's where it gets really interesting. You found a detail in the manual about that distance, and it turns out it's not always the same.
Yeah, this is fascinating. I saw a chart, and if you're looking at, say, an unencrypted signal like a spreadsheet, you can go the full 6,500 feet.
2 kilometers.
Yeah. But if you decide you want to watch a movie, the distance just drops. It goes all the way down to about 1,600 feet. Why? Why does the cable care if I'm watching Excel or Star Wars?
It's all about HDCP.
The copy protection.
High bandwidth digital content protection. Exactly. It's the encryption they use for movies and streaming. HDCP requires this constant digital handshake. The source is always yelling, "Are you a secure device?" And it needs an answer back almost instantly.
And if the monitor is a mile away?
The speed of light is fast, but it's not infinite. That round trip for the handshake just takes too long. The source doesn't get the yes back in time, and it assumes someone is trying to pirate the signal.
So it cuts the feed.
It just cuts the feed. The physics of the extender works perfectly, but the security protocol itself panics.
Wow. Okay, so speaking of fine print, I saw the device has ports for everything. USB, infrared for remotes, even RS-232 for serial data. So I can just plug in my keyboard, my remote, everything, and it all works.
You would think so. I mean, that's what you'd expect. But there's a huge gotcha in the manual.
Let me guess. A DIP switch.
You got it. A physical DIP switch on the transmitter and the receiver.
No way. So I have to physically flip a switch on the box. What for?
You have to choose which one of those extra functions you want to extend. You can pick USB or IR or RS-232.
Wait. Or, as in you can't use them all at the same time.
Correct. The manual is very clear. Only one function can be used at a time.
So if I'm in a control room and I need to type on my keyboard, I can't also use the IR remote for the big screen on the wall.
Not unless you want to take a walk, a mile-long walk back to the other box to flip the switch.
That feels like a massive limitation. You get this perfect crystal clear video, but you lose basic multitasking.
It's a classic engineering trade-off. They clearly prioritize that 18 Gbps video stream above absolutely everything else. All those other signals probably share one tiny data channel.
So wrapping this all up, what we have here is an amazing box that uses light to move a workstation interface across a campus.
Right, as long as you're not trying to watch a protected movie from too far away or, use your keyboard and a remote control at the same time.
I think what this really shows is the untethering of the workstation. We're so used to our computers being these physical boxes we're tied to.
Exactly. This proves that the computer can just be an abstract resource somewhere on the network. The box itself doesn't need to be physically present, it just needs to be accessible.
It really makes you think then. If we have the technology right now to separate the user from the machine by over a mile with what feels like zero latency, at what point does the physical location of our hardware just stop mattering at all?
A great question to end on.
Thanks for listening to this deep dive. We'll catch you on the next one.